Is more of an introduction to my PhD study, which is entitled The Supracrustal Architecture of the Eastern Michipicoten Greenstone Belt in Ontario. This is about one of the first times we've shown this, this project at a Metal Earth meeting. So this project is a joint project between Laurentian University and the Ontario Geological Survey. My academic supervisor at Laurentian is Stefan Perotti, and then we have a committee member, Dan Gibson, at Simon Fraser University. So a brief outline of what today's presentation is going to look like. I'm going to briefly go over the project background and then introduce my PhD research objectives with some very preliminary results, the next steps, and then just a summary of those at the very end. So jumping into the location, we are located, this project, within the eastern part of the Wawa subprovince, right next door to the Abitibi. And of course we are separated by the Kapuskasing structural zone between them. So my study area is looking at the Michipicoten Greenstone Belt, which is on the easternmost extent of the Wawa subprovince. So zooming in to the Michipicoten, most people look at it, it's considered to be moderately endowed, especially with gold when compared to the Abitibi, and it's best known for the currently producing Island Gold Mine and Magino Mine, as well as the past producing Renabi Mine. So getting into the architecture of this greenstone belt, it's a pretty classic granite greenstone belt of the Superior Province, consisting of ultramafic through felsic volcanic rocks, ultramafic through felsic intrusions of various ages, and then the chemical and clastic metasedimentary rocks. So the Michipicoten was separated into distinct assemblages in the 1980s by SAGE, identifying the Hawk, the Wawa, and the Catfish assemblage, respectively at 2.9, 2.75, and 2.7 billion years. And these were interpreted to be overlain by the Dore metasediments in the north and throughout the belt. So the assemblages within the Michipicoten have previously been interpreted as similar to the Abitibi, but there are some very notable and distinct differences, those being first and foremost the presence of the old 2.9 billion year old Hawk assemblage in the south. Then there is a notable difference also is that there has been an interpretation for a less continuous volcanism than what we see in the Abitibi, so that we're missing the previously understood to be missing the ages between that 2734 and 2710 from Deloro age through Kid Monroe. And then another distinct difference within the Michipicoten is that the metasediments of what's been defined as the Dore metasediments have been lumped together in one understanding. So whereas in the Abitibi we know that the turbidites and the conglomerates have distinct ages and distinct histories. So this brings me to our study area, or my study area, in the eastern portion of the belt. From this vantage point, the models from the west and the understanding of the belt has some issues. First and foremost being that we have some fault discontinuity here, and the understanding of how these faults are interacting on this part of the belt is not very well known. And then we also have this abrupt halt of the Dore metasediments at what is the Meath Lake Fault. I'm just going to turn on a laser pointer so I can show you there. So abrupt halt of the sediments along what is the Meath Lake Fault in my part of the world. So I'm just going to move on to our preliminary revised map. So this map has been a long time coming. It was put out for the first time this year in my 2023 summary of fieldwork, and it's a compilation of mapping that has been ongoing from an OGS project that was initiated in 2013 by Lise Robichaud. I have since adopted that project with staffing changes and have ran with it into where it is today. So some adjustments that we can already see that this map has kind of solved from the previous understanding of this part of the world is that our faults now, we understand what the relationships are, give or take, between them. And then it's the other thing that we've added recently is that we've been able to continue these metasediments within the north. So there's got rid of that discontinuity as well. So within the 2013 to 2018 mapping, the geochronological ages that were coming back from with this part of the belt gave supracrustal ages between 2740 and 2695, intrusive ages from 2741 to 2661. And then just a note that most of these ages are primarily done using TIMS. So this kind of, I'm introducing where the inspiration for this project came from, is primarily with a lot of these supracrustal ages that were returned from the belt. They are with ages from like around 2720, 2730, and then these 2704, we can start interpreting that the volcanism within the Michipicoten was much more continuous than previously interpreted. And the ages that are coming back are lining up a little bit better with what we do know from the Abitibi stratigraphy. So this is just a slide to have them all in one place in case we need to refer back to. I'm going to be systematically going through the research objectives for this PhD study throughout this talk. So first objective will be to update the volcanic assemblages of the Eastern Michipicoten Greenstone Belt. So the questions that we will be asking are, what are the assemblages? How do they compare with adjacent belts and subprovinces? And then what are the implications for continental growth in the Southern Superior Province? So we'll be doing this using recent bedrock mapping, geochronological data, and then whole rock and trace element geochemistry. So first focusing in on some of the bedrock mapping that's been done up in this northern part of the belt, looking at the youngest volcanic rocks in the area. We were actually able to put a bachelor student from Queen's University on the project, looking at the Convoy Lake Prospect, which is a base metal and gold enriched package of garnet-bearing intermediate volcanic rocks that kind of fit within that realm of our Lake River age known for the Abitibi. So that was the interest for having her look at this. So Sarah's project, she observed VMS-style mineralization with late gold and late metamorphic overprint from outcrop mapping and a petrographic study that she did last year. So this detailed study will help us get a better grasp on the phases of mineralization and related deformation that have affected these assemblages. And then digging into what more I'll be focusing on is trying to pull apart the assemblages within this part of the belt. So these are just ages. They're not, we're not saying that they are the same stratigraphy. I've been able to just tentatively draw some preliminary boundaries for some of the units that we can understand so far from current ages. And then what we hope to do is, through more geochronology, fill in the gaps to be able to interpret the rest of the assemblages throughout this part of the belt. So geochronology, we are doing a pretty big spread of ages from across this part of the Greenstone Belt. So last year we had 22 samples sent out. We'll be on the laser hopefully as soon as I'm back to Sudbury, now that it's working, to get that dated. And then we've also sent off another 26 samples from 2023 mapping, which will be ideally getting done before the field season, if not shortly after it. We've sent out TIMS, and then we'll be following up our uranium lead with lutetium hafnium. What we are also doing as part of this, because we have so much availability of the OGS samples, I will be reanalyzing a lot of our samples from the previous analyses that were done with TIMS, and then some of them I'll be rerunning the ones with laser if we find we need more data points. And then following up on this, if we find that we need to draw these lines with the geochronology, we'll be doing TIMS on some specific zircons that we've already lasered. geochemistry with across the belt. So of course we've got 10 years of sampling. So I have so far just under 1,200 whole rock major and trace element samples submitted to date, and then we'll be having an additional 300 between last year's and this year's sampling. So what we're hoping to do is expand these updated assemblages that we've looked at in the eastern part of the belt using either historical data or ongoing data that's coming out to expand these assemblages to the rest, and then compare them to adjacent greenstone belts to try to define the broad tectonic implications for the Southern Superior Province. So we're hoping to compare not only to the Abitibi, but also look to the west in the rest of the Wawa, and then potentially even into the Wabigoon, depending on what our results are going to be. So moving on to the second objective of this project will be to look at the detrital zircon geochronology of metasedimentary rocks within the eastern Michipicoten greenstone belt. So I've just, to make them a little easier to see, I've highlighted where these some of these sediments are throughout the belt here in black, and then of course there's the one that's easier to see up here in the north. So just a reminder that previous compilations of this area have all looked at this and considered it as volcanic, whereas we are very clearly seeing lots of sediments. So what we're looking at is trying to answer is what is the nature, age, and geodynamic setting and gold exploration implications of these multiple clastic metasedimentary units within the Michipicoten greenstone belt. So there's two flavors of sediments that we're observing throughout the belt. The one that's a little more abundant is our turbiditic rocks, which we see quite a lot of up here in the north. They're increasing from green schist all the way up to amphibolite when we get closer to the granitoid complex up there and the gneisses. And then we see them also throughout the belt. The second flavor of sedimentary rocks we're seeing is our heterolithic metaconglomerates, which we are primarily seeing localized along major structural zones and zones of intense deformation. So those would be the Baltimore Deformation Zone, and what we've determined recently was the Easy Lake Deformation Zone, and another one up here, which is along the south shore of Wabatungushi. So these are heterolithic, consisting of intrusive and volcanic rocks that are surrounded to subangular. Locally, we are getting magnetic material incorporated into them as well. And then up here in this one, because we are so close to the gneisses to the north, we're also seeing leucosome incorporated into this particular sample. So what we're going to be doing with all of the metasedimentary rocks throughout the belt is detrital zircon geochronology to try to see if we can pull apart these turbidites versus conglomerates within this part of the belt. So what I'm showing here is a sample that we are going to be rerunning and try to get some more data points on. So this was the Baltimore Lake conglomerate that was dated in 2015, and so the unfortunate part about the way that it was dated is that we had only 64 spots that were used to determine a peak age at the 2695. So what this method, and unfortunately the number of spots, shows us is that it's really important for us to look at the detrital data and maybe make a more robust interpretation of a maximum depositional age. We are going to be reanalyzing the sample to see if we can pull out some of these younger dates that are present. And so I've just thrown the table across the bottom as more of a representation to show you that we have considerably younger dates coming back out of this particular sample, and that I think a bigger data set to give us a better statistical age to determine the maximum likelihood or maximum depositional age of the sediments. So coming back to these deformation zones and our bedrock mapping, something very significant that's associated with these conglomeratic rocks is the deformation zones. And so the Easy Lake Deformation Zone in particular hasn't ever been identified within this location just because of the challenging access to get up into this part of the belt. And what we've noted with this particular deformation zone is that it is juxtaposing volcanic rocks to the south with these sedimentary rocks that we see here to the north. So along the Easy Lake Deformation Zone, we see shear sense indicators, both sinistral and dextral, with primarily we're looking at dextral if we're going to average them out. All right, so moving on, what we want to do with this objective is to see if we can redefine these Dore metasediments and pull apart if they are similar to the Abitibi with our turbidites and our conglomerates as distinct units. And that what we also want to look at is how to link these relationships we're seeing to the sediments with the regional east-west deformation zones. Yeah, so looking at, we don't have to look very far to look for a comparable setting to where we see this juxtaposition of our volcanic rocks with our sedimentary rocks when we look to the west, to the east, to the Abitibi. And that these deformation zones can be a notable comparison to the Porcupine-Dester and then potentially the Larder Lake Cadillac Deformation Zone. So something that we want to test is to see, do we have analogs to the Porcupine-Dester or the Larder Lake Cadillac within the Michipicoten Greenstone Belt, or another hypothesis that we're going to want to run with, because the data is there, is to see if we can continue these deformation zones across and interpret. Yeah, so this is something that we want to throw up in this context to see what what thoughts are, what could come out of this as our scientific hypothesis. So I'm switching gears here to another objective of this project, which is a more method development part of the project, which will be the hyperspectral mapping of metamorphism and alteration at greenstone belt scale in the eastern Michipicoten Greenstone Belt. So what we wanted to look at is what are the temporal and genetic relationships and gold exploration implications between hydrothermal alteration and the metamorphic evolution of the supracrustal assemblages. So this is not a figure from the Michipicoten Greenstone Belt, as you guys can see, it's from Malarctic, and this is just shown here as an example of a successful way that hyperspectral imaging was applied to map out the metamorphism and alteration around a known gold deposit. So just a reminder of the scale of this example is at a 15 by 10 kilometer scale, whereas what we want to do is see and test this method at a much larger, almost greenstone belt scale. So what we're trying to expand on is take this to a 40 by 40 kilometers and sample and submit samples, so primarily of supracrustal rocks, just because that's the focus of this study. And we've also looked at we've submitted samples from around the Renabi gold mine just to be consistent with what we have in the area. So we've sent 830 samples to get analyzed by hyperspectral. We're using shortwave, midwave, and longwave infrared to look at how the different mineral chemistries across the belt and see how those might link to alteration and metamorphism. So we don't have our data back yet, it's on the way, so I'm hoping to get to share that with the group eventually as we get that back. So the final objective of the project was developed more as a contingency plan in case we run into issues along the way, and it was based on some of the stuff we were observing throughout this last summer in the field. And this will be to define the potassium-rich intrusions of the eastern Michipicoten Greenstone Belt, looking at their ages, geodynamic setting, and metallogenic implications for them. So just some background on this one. When we were mapping the previous interpretations for this part seemed to have oversimplified the intrusions within the area. And so we had expected to come in and just see tonalites to granodiorites, and that was what we did not, that's not quite what we saw. So what we were looking at as we were moving from up here to down in this part is a gradation from a deformed tonalite into a granodiorite And then then there was an actual contact at this specific spot with more quite quartz-cyanitic rocks. And then as we moved further to the south, we got into more of a cyanitic rocks within the belt. So just a note that what we're observing here was also close to one of these deformation zones, slightly different than the east-west ones we were looking at earlier. But we do also have several suites of our different intrusions of this potassium-rich nature across the northern part of our study area. So the ages that have come back for these ones within my study area, as well as further to the west of these granitic to cyanitic intrusions, are 2670. And they all have a spatial association with some of these east-west deformation zones. And then previous literature has, in this part of the world, looked at these intrusions as having a spatial association with gold. And again, in terms of significance for the rest of the Superior, this tectonic setting is pretty critical elsewhere, namely at Kirkland Lake, where we have these Temiskaming aged alkalic intrusions spatially associated with gold. So it's just highlighting another aspect of this belt that may have been overlooked in the past, or it might be worthwhile to have a modern perspective look at. So yeah, just a summary, that's the objectives we've got and some of our field assistants. And